Hey, what's up everybody? Chris here with another Proto Tech Tip. Now this week we're going to be jumping into the topic of bend tolerances. So let's get into it. In a recent Proto Tech Tip, we covered the basics of sheet metal tolerances, and if you missed it, don't worry, just check out the link in the description below to watch it. So in today's video, we're going to dive further into the topic of tolerances and talk specifically about bending tolerances. In manufacturing, bending tolerances refer to the acceptable variation between the specified bend geometry, whether it's angle, radius, or position, and the actual result after forming. This is crucial for making sure that parts fit and work as intended, especially in assemblies where precise alignment really matters. Bending sheet metal comes with certain challenges like material springback, stretching, and compression, all of which affect the final dimensions of your part. Tolerances are the agreed limits that account for these unavoidable variations. Now, bends in sheet metal and their corresponding tolerances either pertain to a controlled dimension or an uncontrolled dimension. Controlled dimensions refer to the length of the flange of any bend. Controlled dimension bend tolerances are standalone and therefore do not need to be considered in relation to any other bend. Uncontrolled dimensions, however, on the other hand, refer to the other areas of the part where the bend starts. These dimensions include two types of tolerances: all of the manufacturing tolerances used up to that point, like laser cutting and welding, and all of the bend tolerances for the whole entire part combined. So we call this an uncontrolled dimension because there are extra tolerances to think about. Basically, all of those tolerances get added up, or in other words, they stack up. And side note, we're going to dive deeper into stack tolerances in an upcoming tech tip, so please keep an eye out for that one. So at Protocase and Protospace MFG, we stick to a tolerance of plus or minus 1 degree for the bend angle and plus or minus 0.010 of an inch or 0.25 millimeters for the bend length. Now let's go through some factors that influence bending tolerances. First and foremost, material thickness plays a big part. Thicker materials tend to have a wider tolerance on the nominal thickness, resulting in greater part-to-part variation in uncontrolled dimensions. Bend geometry is another factor. So when it comes to bend radius, very small bend radii typically induce more stress and greater variation, and thus tolerance issues on thicker materials. On the other hand, while larger radii provide smoother bends and easier control, profoundly large radii, like say 10 times the thickness, also induce greater variation due to the large amount of springback that must be compensated for. Meanwhile, sharper angles, say beyond 90 degrees, tend to accumulate more springback and variation than shallower bends. But in summary, tight bend radii and sharper angles often result in more variation, making tight tolerances harder to achieve. Now, overall part size and proximity of features are also an important factor that affect bending tolerances. Larger parts can accumulate more variation due to any sagging, handling issues, or uneven force distribution during bending. On the other hand, features like holes near the bend line can distort during bending, influencing final tolerances and requiring careful considerations. So by considering these factors during the design process, you can cut out any surprises or costly iterations later on during your project. So that's it for this week's Proto Tech Tip. Please leave a like and subscribe to our channel if you enjoyed this video. And remember, if you ever need assistance with your next project, our account managers and engineering and design service experts are here for you. Just reach out by filling out the contact form on either website. The link is going to be in the description below. And that's all for me for this week. Please take care, and we'll see you all again next time.